Hey, Math Muscle back here again with a video on integration by parts. Here you see in purple the formula that we'll be using. I'll jump into on the next slide here how to use it. And basically we're going to use integration by parts as like our third option for methods for integration or techniques for integration. And it's typically after any traditional or basic methods and U substitution have failed you. So let's go ahead and get into a few examples and see how to use integration by parts. All right, so in our purple formula, what we've got is u and dv. And what we're going to do with u and dv is we're going to set up the equation on the right side as well using our knowledge of differentiation integration. So here are the 4 steps that I typically use in integrating using integration by parts. First of all, you got to identify the need for integration by parts. It's somewhat more complicated than the other methods. So if you have a simpler method that works, go with it. Okay, so we need integration by parts. We've confirmed that. The second thing is we need to identify u and dv using the Lippitt method. I'll show you what that is in our example below. The third step is to find du and v, which means we're going to differentiate u and integrate dv. And then the fourth step is we're going to integrate and simplify. So let's get to it. Step 1, I look at this blue function. I want to integrate it. U substitution will not work in this situation. Neither will traditional methods of integration. So I've identified that I need to use integration by parts. So step 1, I've checked. Step 2, I need to identify u and dv. So the Lippitt method goes like this. Okay, I've got Lippitt. I kind of write it in this vertical orientation where L stands for logs, I stands for inverse trig, P stands for any polynomial, E stands for exponentials, and T stands for trigonometric functions. Now U is always up on the priority list and dV is always down. So let's identify the 2 functions that we have. We have x, which is a polynomial function. All right, it's just a linear function. And then we have e to the x, which is an exponential function. And along with e to the x, we actually tag onto it dx. So whatever your dv is, you always tag the dx onto it. Okay, so now that I know that u equals x and dv equals e to the x dx, we have checked step 2. Let's move on to step 3. So step 3 is to find du and v. Okay, so I'm going to find du. So if u equals x, then du is equal to 1 dx. Okay, so how did I do that? I did this. Here's u is equal to x. I took the derivative of u, du dx, with respect to x, and I got 1. But I don't want necessarily to know du dx. I want to know du. So I multiply both sides by dx. So you're always going to end up with that dx over on the right side. So du equals dx. Okay, now if I've got dv and I want v, I just integrate. So if I integrate e to the x dx, conveniently that ends up being e to the x. Okay, so we wouldn't put a constant of integration, a plus c on there, because we're going to add that in at the very end. Okay, so now we're going to use our purple formula and we're going to integrate and simplify. So if I use my purple formula and I've got the integral of u dv is equal to u times v minus the integral of v times du. I'm going to use that formula in its simplest form here to then rewrite the following. So what was u? U was x. And v is e to the x minus the integral of v, which was e to the x, times du, which is dx. Okay, so we're almost complete. We just have to do a little bit more simplifying. Again, we're in step 4 here. So the integral of x e to the x dx is going to be equal to x times e to the x minus the integral of e to the x. And we know the integral of e to the x is itself. And now I'll add in that constant of integration. And there we have it. All right, let's do another example. Okay, let's attempt this question here. We're going to integrate the following. Traditional methods and U sub are no good on this, so we're going to attempt integration by parts. So I've identified that I need integration by parts. Now I got to identify U and dv. So I would go with, let's line up our Lipit setup. Okay, U being up, dv being down. Logs, inverse trig, polynomials, exponentials, and trig functions. So inverse trig and trig, keep those separate. All right, so I've got x as being the polynomial function. So I got x. And let's see, I've got cosine 3x. So it looks like that'll be a trig function. And I'm going to tag on the dx onto that one. Okay. So I know that u equals x and dv equals cosine of 3x dx. Now, there's need for basic integration and differentiation here, so those skills need to be sharp. But du will be the derivative of x times dx, so that'll be 1 dx. The integral of cosine of 3x, okay, think about this, the integral of sine, the derivative of sine is cosine. So I'm going to have to account kind of using a u sub here by having 1/3 sine of 3x. Okay, the derivative of that would be cosine of 3x. Okay, so now we're ready. We're set to go. So the integral of what we're looking for will be u times v minus the integral of v times du. So uv will be, I'm going to rewrite this as x times sine of 3x over 3 minus the integral of v times du. So I'm going to pull the 1/3 out because that's part of v and put a sine of 3x du, or in this case dx. Okay, so we got just one step left. We got to integrate sine of 3x dx. And of course, the derivative of cosine is closely related to that. So what I'm going to do is I'm going to rewrite, no change here in this first term. And I'm going to place a negative 1/3 here, and then I'm going to integrate, let's go purple, this. Okay, so let's integrate to the side, sine of 3x dx. Okay, so you could do this a couple different ways. You could use a u sub. You could just know that you have to account for the 3 that's going to come out using the chain rule type situation. But I know that the integral of sine is negative cosine, right? And then because when I take the derivative of cosine of 3x, that 3 comes out, and I don't see the 3 showing up here, I got to account for that with a 1/3. Therefore, I would have negative 1/3 cosine 3x, and then plus c. Okay, so here we go. We're going to finish this off. We're going to have the answer to our original, which we'll rewrite in a second, but I'd have x, times sine of 3x over 3 minus, plus cosine of 3x over 9 plus c. And there you have it. That is the integral of x cosine 3x dx. All right, those are some basics on integration by parts. I'm going to do a second video on some more complex scenarios, as well as some definite integrals. These are indefinites without limits on the integral notation. So hope that went well. Let me know if you've got specific questions. See you in the next video.